Okay, so let's take a look at some factoring here, and specifically factoring by grouping. As you can see, we've got these four terms, and in each of the terms there doesn't seem to be something that's common to all of them. I see x, x, x in the first three, but no x in the last one. I see y's in these two, but not in the others. I see a z in the second and a z in the fourth, but not in the others, etc. So there's nothing really common to all of them. So sometimes it's possible to look for something that's common in just the first two terms. For example, let's say that there's x is common in the first two terms. Now, if this works, whatever I get here, I'm going to have over here as well. Guaranteed. If it doesn't happen, I can't factor by grouping. So in this case, if I factor out an x from the first two terms, I'm left with 2x, because x times 2x is 2x squared. If I factor an x out of the second term, I'm going to have this positive sign and z, because x times positive z is positive xz. Now, for this to work, this factor has to be the same. So I just write it out that way, 2x plus z. I know it's going to be that way. And then I ask myself, what do I multiply 2x by to get 6xy? And it has to be positive 3y. Now, if this works, the next one's going to be a gimme. Is 3y times z equal to 3yz? You betcha. So I know it gets a little messy here, so let me just rewrite this. So I had x and 2x plus z plus 3y and 2x plus z. That means 2x plus z is common, so I write it once. And x and 3y are what I call my leftover bits, so that makes my other factor, x plus 3y. There we go. We factored by grouping. Now the next stage is to factor trinomials in this form that we call x squared plus bx plus c, where the number in front of the x squared term is 1, usually not written. So an example of that would be something like where the instruction is factor x squared plus 3x plus 2. If I could rewrite this as two terms, something like x squared plus 2x plus 1x plus 2, then they could do like what we just did. We could factor by grouping. Look at these two terms. What's common? The x's. What's left over? Well, what do I multiply x by to get x squared? It has to be x. What do I multiply x by to get positive 2x? It has to be 2. And I know that whatever that bracket is, the other one has to be the same. Now this one's a little tricky because some people think, okay, what do I multiply x by to get x? Well, I've already got x. So what do I need? But you have to put in the positive 1. And then double check. Is 1 times 2 equal to 2? Sure. So your factors are x plus 2, the common one, and the leftover bits, x plus 1. But how do you choose these numbers? And that's what I want to show you next. So I've written the question again, and we're just going to move that up here. So we've got x squared plus 3x plus 2. And we're trying to find a way to break this guy down into two parts. So we'll have x squared, we'll have something, something, and plus 2. But how do we get that something, something? So here's how you do it. Find two numbers that multiply to give the last one, and add to give the middle one. Don't worry about the x, just the numbers. So in this case, it's fairly easy. There's only two ways you can get 2. It's either 1 times 2 or negative 1 times negative 2. So what two numbers multiply to give 2 and add to give positive 3? And hopefully you can see that it has to be those two. So what we do with them is we rewrite them. So we've got x squared plus 1x plus 2x plus 2. 1x plus 2x is 3x. That's fine. Okay. Now let's see what happens. What's common? We'll factor by grouping, right? So we've got x times